Okay, so this video is going to be going over chapter 37 in my book, Overcoming Digital SAT Math. So this is the polynomial division chapter. Now I want to preface this video with saying that basically you don't need this video for digital SAT, probably. But just to be safe, I put it in there anyways. And also a lot of people struggle with polynomial division in general for like their algebra classes. So I figured it'd be helpful for a lot of people anyways to just include this. So in the video description for this video, there's going to be a link to me reviewing the notes for this portion and giving you an example of synthetic division and long division with polynomials. So I would go and watch that video in the description before attempting the problems on your own first, if you have a copy of this, and then attempting corrections on your own and referencing this video for explanations on anything that you're stuck with, that you just can't correct on your own. So with that being said, let's go to the first question right here. Now, personally, I prefer doing long division with polynomials. Synthetic division, just like my brain hates it for some reason. I actually find the long way easier. So that's what I'm going to do here. So this would be how I set up the problem, because it's just the top divided by the bottom. So what you're going to do here is very similar to the long division you're used to in 4th and 5th grade. It logically works, so that's, again, why I like this. So you basically ask yourself, okay, I'm going to look at the x portion, just the x portion right here, and I'm going to say how many times does it go into 2 times x to the third. You can also think of this as like, what do I need to put up here and multiply x by to get back to 2 times x to the third. So what do I have to do? I have to put x squared, that's supposed to say 2x squared up there. And then what do you do typically after that? You multiply. So I'm going to multiply the new thing I brought up here times this whole thing. So 2x squared times x is going to give me 2x cubed. 2x squared times 3 is going to give me plus 6x squared. And then what do you do after that typically? You subtract, right? So these cancel out, and then I have negative 5x squared minus 6x squared, which gives me negative 11x squared. And then after that, you're supposed to bring down, so let's bring down the negative x. So now I need to go through that process again, but this time I'm asking myself, okay, how many times does x fit into negative 11x squared? So that's going to be negative 11x. And then now I multiply negative 11x times all of this. So negative 11x times x is negative 11x squared. Negative 11x times 3 is negative 33x. And then I need to subtract all of this. So then these cancel out, and then minus a minus is a plus. So that would be 32x right there. And then I have to bring this down, the 3, or the plus 3 technically. And now I repeat the process again. How many times does this x go into 32x? Well, that would be 32 times, so plus 32. And then I have to multiply that times the x plus 3. So then that's going to give me 32x plus 96. And I have to subtract that. These cancel out, and I get negative 93. So there's nothing left to bring down, meaning this is my remainder. So think back to when you were doing like mixed numbers and stuff, and you had to do the long division way to figure out from the remainder what the fraction part was next to the mixed number. It's the same logic that you apply right here. The remainder that you're adding on is going to be this, negative 93, over what's on the outside right over here. So the same thing you're used to doing with mixed numbers. So this is the remainder, right? And you'll see it matches what's right there. So K must be the other part of the problem, meaning the answer is A. Now for this problem, I'm going to show you a trick. I did do this in the notes video, I believe, as well. But just to cover all bases, I'm going to show you how you would do it here. So what I usually say is like pick x, or you know what, actually, since I already did it in the video that way, maybe I should do the division way here. Let's do that. That way I can show you like 2 different versions. So pause to read number 2 if you haven't already. So I'm going to say how many times does x fit into 6x, and that would just be, you could also think of it as 6x divided by x, or x times what gives you 6x. All of that's the same. So it would be 6. So now I multiply 6 times x is 6x. 6 times negative 3 is going to be negative 18. So then I have to subtract this. These cancel out. And then minus and minus is a plus. So it's plus 18. So then it's going to be 6. And then I add on the remainder over what's on the outside, x minus 3. So let's see what fits that. And that's just a. The same exact thing as a. Now, just as a side note for the previous problem, I would encourage you to go and watch the notes video to see the equivalent expressions trick that I was talking about, because it can be very helpful on the exam. So just as a little side note. Anyways, pause to read number 3 if you haven't already. Okay, so if I'm being told that y plus 3 is a factor, that means whatever the opposite of the thing right here is, or basically you could think of it as, because it's not always going to be the opposite, like if you have a coefficient right there, you can think of it as it'll always be that this equal to 0. If you set that equal to 0 and solve for what y is, so I'm going to subtract 3 from each side to say, okay, that means y must equal negative 3. That if you set that equal to 0 and solve for y, that value, if you were to plug it in for y into the expression, you should get that the entire expression equals 0 if this is truly a factor of the given expression. So let's plug in everywhere we see y and negative 3 and then set the polynomial equal to 0. So that's exactly what I did. The only thing I did was plug in negative 3 everywhere I saw a y. So now I'm going to do all the exponents and multiplication parts. So negative 3 cubed is going to give me negative 27, and then I have to do negative 27 times 2, which is going to give me negative 54. And I'm going to do that now for the rest of the problem. And then this is what I get. Now I see negative 54 and 54 easily cancel out, so I'm going to do that. And I'm going to combine my terms of 33x and 3x, and I get this. Now, remember, I want to solve for what b is, so I'm going to subtract 36x from each side, but still the x's cancel out. And then now I'm going to divide each side by negative 9 to get b completely by itself. And I get that b should be positive 4, so that's my answer. Pause to read number 4 if you haven't already. So for one of the answer choices to be a factor, that means that when we plug in 2/3 as our x, we should get 0 as the answer. So basically we're going to do that for x in each of the answer choices and see if we get 0. So for a, that would be 2/3 minus 3. That's definitely not 0. For b, that would be 2/3 plus 3. Again, definitely not 0. Now c is 3 times 2/3 plus 2. The 3's would cancel out. 2 plus 2 is definitely not going to equal 0. So not c. Now for d, we have 3 times 2/3 minus 2. So the 3's cancel out. And we have just 2 minus 2, which is in fact 0. So the answer is D. Okay, pause to read number 5 if you haven't already. So another way of saying that it's divisible by x plus 5 is saying that x plus 5 is a factor of the polynomial. So remember, if that's a factor of the polynomial, that means when we set it equal to 0 and solve for x, that x value, if we plug it into our polynomial, should also get us 0 for our polynomial. So let's solve for x by subtracting 5 from each side. So that means x is equal to negative 5. So basically, everywhere I see an x in the answer choices, I should plug in a negative 5. And if I end up getting that this entire thing, like when I put negative 5 there, and do all the math, if I get that the whole thing right there is equal to 0, then I know that it is truly divisible by x plus 5. So I would have to do that for each of my answer choices, and once I get 0, I have my answer. So all I did for answer choice A is I plugged in negative 5 where I saw an x, and I'm going to see if that makes f of x equal to 0. So let's solve. Remember PEMDAS, I'm going to do my exponents first right now, and I get this. And now I'm going to do my multiplication, and now I just need to add this all together. Technically, I don't need to because I know just from seeing that it's not going to equal 0, but you can if you want to. So I'm going to just go ahead and go to B. Because I know since this is not 0, that it's not going to be answer choice A. So now for B, I'm just plugging in -5 for x. Again, I'm going to start with my exponents. And now I'm going to multiply. And then if I do 75 plus -55, that's just going to be 20. And then I have 20 minus 20, which is obviously 0. So it does in fact equal 0, so it should be B. Okay, pause to read number 6 if you haven't already. So to know whether each answer choice is a factor of the polynomial above, we need to first set the answer choices, each of them, equal to 0, and solve for x. So when I do that, this is what I get for each of the x's for the answer choices. Now I need to plug in each of those x values to see if that makes the entire function equal to 0. Because if it ends up equaling 0, that means that that corresponding answer choice is in fact a factor of this polynomial. So let's see if A is correct by plugging in -4 for x. So I plug in -4 for each of the x's. Now I'm going to do my exponents. So I'm going to multiply 8 times 16. And when I do that, I get this. So now I'm going to add this all up. And when I do that, I get 0. So since I did get 0, that means this is in fact a factor. So that works. But I see answer choice D says it could be both A and B. So now let me check B to make sure that it's not also, that it couldn't be answer choice D. So I'm going to plug in 1 for x now and make sure that I get 0. So I just plugged in 1. Now I'm going to do my exponents. Now I'm going to multiply. And now I'm going to do all the addition and subtraction. And when I do that, I get that it does in fact equal 0. So that means B works as well, meaning the only possible answer choice would be D, both A and B. So we want to pause to read if you haven't done this already. For this problem, we want to figure out what the remainder is when P of x is divided by x plus 2. So if we're dividing by x plus 2, another thing that we could think of is, okay, let's plug in what x is when this is equal to 0. So let's solve for x by subtracting 2 from each side. And that gives me x is -2. So I'm going to look at my table for where x is -2. And whatever I get for P of x there has to be my remainder. So my remainder is 12D.